Well, thank you for coming today. I want to talk about not my research, our research per se, but the reason why we're doing the work that we're doing. And the way I want to structure that is to look at manufacturing across Alabama, a little bit of history, what's going on today, and maybe some glimpse as to what the future may hold in this area. Alabama's been blessed with a lot of natural resources for manufacturing, in particular for the iron and steel industry. A lot of iron ore, coal, limestone, right here in Alabama, basically around Birmingham and north of Birmingham. That led quickly to the rise of an industry to take advantage of those resources. In fact, on the chart you see the locations of iron furnaces scattered around Alabama before 1860. You see one star labeled with blue, and that's the Tannehill Iron Works, which is considered to be the mother of the iron industry in Alabama. If you're a history buff, or if you're a manufacturing buff, or if you really like both, that's a wonderful state park to go visit. Really nice museums, restorations, and things like that. The Tannehill Iron Works supplied a lot of iron to Selma, Alabama in support of the war effort in the South. Turns out Selma was, all the manufacturing plants were destroyed by federal troops in April of 1865. And so all of that was destroyed 5 days before Lee surrendered in Virginia. So one thing which was not destroyed is this old iron lathe. This happens to be located here on the Auburn campus just north of Samford Hall. Nice plaque that goes with that. Picture of Birmingham. That iron industry really continued to grow even after all the destruction with the Civil War, leading to Birmingham being named after Birmingham in England. This is a nice picture from circa 1950. Probably a cold front had just come through and cleared the sky of all the smoke and soot from Birmingham to make such a nice picture. Metal casting and the iron industry is hot, dirty work. Typically has tended to be well-paid work, but nevertheless, hot, dirty work. I'm a metal casting guy by training and experience over the years, and so I really relate to this picture. I like this stuff. Many people, particularly next generation, don't really like that stuff. Around the time that picture was taken in 1950, Werner von Braun moved from Texas, from Germany to Texas and then on up to Huntsville, and moved 1,000 engineers, rocket scientists and engineers into the Huntsville area. That led to the growth of Huntsville. Huntsville started out, before von Braun showed up, had 15,000 people. Pretty good sized town back in the 50s. Now it's the third largest town in Alabama. In 3 or 4 more years, it will be the second largest town in Alabama. In the early 90s, the automotive industry found Alabama, started the Mercedes plant. That led to Honda and Toyota and Hyundai and Kia across the way. Now, the state of Alabama is the 5th largest car production state in the country. Big, big business in this state. A few years ago, Airbus located a plant down in Mobile. Basically, Airbus brings in large sub-assemblies, assemble those at the plant there, and then sells those, delivers those to their customers. That facility is going to continue to grow over the years, and hopefully more and more of the sub-assembly work will be done here in the state of Alabama. Currently, it's shipped in. Those large sub-assemblies, wings, fuselages, ailerons, and things like that are shipped in from Europe. Now I want to really start drilling down on things that are particular of interest. A few years ago, GE located a plant here in Auburn, Alabama. 3 years ago, they announced that plant was going to be the focal point for the world's first high-volume additive manufacturing plant in the world. And so the idea was that GE wanted to make fuel injection nozzles like this, and they want to make 35,000 of those per year using additive manufacturing. Many of you may know that technology more as 3D printing. I'll use the concept of additive manufacturing. Here's a GE picture from inside the plant. showing a number of additive manufacturing machines. These machines are were working when that picture was made. That's a far cry from the foundry picture that I showed you a few moments ago. You don't see any people in that picture. There's a few engineers and technicians going around adjusting knobs and parameters and checking progress, but by and large, these machines are operating unattended. Big, big change from where we might have been a few years back. So, a take-home point. What if you could make whatever you could dream of? In the engineering world, we say whatever we might make. If we could design it, can we make it? So, GE has tremendous technology for designing jet engines. The nozzles inject the fuel into the engine. That's one of the critical parts of that engine operation. The nozzle introduces the fuel in a swirling vortex of an aerosol. The lower left-hand corner is a water model picture of a similar kind of aerosol. So it's basically like the hose pipe at the end of your water hose at home. And GE for years could design nozzles that would give them better performance, but they couldn't build them. Now they can build them. Here's a schematic. I want to go through this reasonably quickly. It shows the powder bed fusion process for making parts. And in powder bed fusion, basically a laser melts powder and creates the part layer by layer. The laser is driven by a beam scanning set of optics. Once a laser layer is completed, then another layer of powder is swept over onto top of the part of the component that was just created. The machine indexes back. The laser is turned on. It travels around the surface in a prescribed way, driven by computers, melting and refreezing powder to create that part. That process is done layer by layer, layer by layer, layer by layer, building that part. It truly is metallurgical magic to be able to make very complex geometries of nickel-based superalloys to be able to go into a jet engine that people are then going to put their lives and trust their lives with for these kinds of components. Here's a picture of the next applications that GE is working on. This is a future Cessna turboprop airplane. That turboprop airplane is going to be driven by what GE calls their advanced turboprop engine. GE is going to use additive manufacturing to make parts for that engine. And they're going to be able to take 845 separate distinct parts and turn those into 11 parts. Those are not simple parts. Those are extremely complex parts. That represents 35% of the engine. It's going to make the engine 5% lighter. It's going to improve the combustion efficiency, the miles per gallon, so to speak, of the engine. It's going to make the engine more reliable as measured by time on wing. This technology is disrupting the aerospace industry in a major, major way. I used to work with companies that I won't name since this is being recorded. I used to work with some companies that made castings, and then they machined the castings, and then they bolted different castings together to make sub-assemblies. They would be expecting to get RFIs, RFQs, basically paperwork from GE to bid on that engine, on components of that engine. That paperwork now is not going to show up. All of that work is going to be done in-house by GE using additive manufacturing. The implications for folks like us in the engineering school, for years we've taught engineers how to design things, and then we make them take courses that we name Design for Manufacturing or Design for Assembly. We tell them you have to be able to make it. You have to change your design slightly, perhaps less than optimum, because it's got to be made. It's got to be assembled. A lot of those rules, additive manufacturing and 3D printing is now changing. Supply chain management. You go over to the College of Business or Industrial and Systems Engineering within the College of Engineering. Lots of courses on supply chain management. It's going to be pretty easy to manage a supply chain that is represented by a single machine making complex parts. And so with that old Jedi Grandmaster, a little bit of wisdom, we've got to unlearn things that people like me have spent a career learning. So with that, that's pretty close.